For multiplying and dividing real numbers, it's going to seem similar to yesterday in that it was a review of things that you've learned in previous years. We're going to add in a little bit about square roots, but besides that, it's mostly review. So the target for today is that I can find products and quotients of real numbers. This should definitely be a review to you. Multiplying real numbers. We did all that hands-on stuff in years past to, drill this in, but it all boiled down to same signs, it's going to be positive. Positive 4 and positive 3 gives you positive 12. Different signs give you a negative. So if I have negative 3 and positive 4, that product is negative 12. I found this cool graphic here. It's kind of like you have these emojis. And so if somebody sends you an emoji like this, you would say, oh yeah, that's a happy face. That's a positive thing. This one is still positive, but if I have like one eye open and one eye kind of, and then the face, it's not going to be a good thing. This is more of a negative thing. In years past, you may have also heard love to hate to love, hate to hate, you're a lover, all that stuff. If you have never heard hate to love to hate, are you a hater, are you a lover, I'll be glad to explain that, or actually probably let one of your friends that was in one of my classes last year explain that to you. For simplifying square root expressions, here's where it's a little bit new to you. If you see something like this, you see a plus and a minus sign out in front of a radical, you're like, okay, what is it, positive? Is it negative? What it means is it indicates both square roots. So the answer to this one, plus or minus the square root of 25, it could either be positive 5 or it could be negative 5. And so we write it like that, plus or minus, on top of each other, just so you aren't having to rewrite things. And in math, we like to abbreviate things. Now down here, if there's just a negative sign in front of it, it's indicating only the negative root to that. So the square root of 1 over 36, or the negative square root of 1 over 36 would be negative 1 over 6, because 1 times 1 is 1, 6 times 6 is 36, and negative times negative, if you were to square that, would take you back to the positive, which is in the radicand there. The inverse property of multiplication. This is not anything new to you. It says the product of a non-zero number and its multiplicative inverse or reciprocal is 1. Big words, but it's not bad. So for non-zero, the reason that it's saying non-zero is you can't really have a reciprocal of 0, and anything times 0 is going to be 0, not 1. For integers a and b, we know integers are plus or minus whole numbers. So this isn't something like 0.25 over negative 3. It has to be an integer. So a over b times b over a, notice they've just flipped it over, is going to be equal to 1. Now let's put some numbers in there. 6 over 7 times 7 over 6 equals 1. That's because 6 times 7 is 42 over 7 times 6, which is also 42. 42 over 42 simplifies to 1. Dividing real numbers. How to do it? To divide a real number, you multiply it by its reciprocal. So think back on adding and subtracting real numbers. You saw that eventually you're just adding those, whether it's adding or subtracting, because you would keep, change. Same thing's going to happen in dividing, except that you're multiplying on both of them. So let's get where you can see this a little better. Okay, instead of keep, change, it's going to be keep it, change it, flip it. And I can tell you a story about a student I had, and I'll just go ahead and tell it now. This girl, she was kind of peculiar. She was the girl that kind of marched to the beat of her own drum, and I was explaining this to her. I was just saying keep it, change it, flip it. I wasn't putting any inflection in my voice. I didn't have any silly story or anything. This is just what you do. And so she was like, oh, okay, Miss Staley, I've got it. You're just going to keep it, change it, flip it. And that's how she would do it every time. So she'd be at her desk and she'd be working and she would just start singing to herself, keep it, change it, flip it. But nobody thought anything of it because that was just how this gal was. Like I said, she was just a tish bit different. So anyway, if you want to, say it like that as you're dividing your real numbers, be my guest. I had another kid last year that kind of made up his own little dance moves to it. So I could show those to you. Can't really show those on this video. So let's take the problem. 20 divided by 3 over 4. What you're going to do is you're going to keep it. You keep the first number, so 20 in black there stays 20. Then you're going to change it. Change division to multiplication. and then flip it. Flip the second number. 3 over 4 flips to 4 over 3. Now, the only thing that can be kind of tricky with this is if that would have been 20 divided by 1 3/4, you would have to change 1 3/4, if you'll remember, to an improper fraction, which would be 7 over 4. So then over here, it would be 4 over 7. That's the only kind of, catch with it. You've got your graphic organizer. You should have adding and subtracting filled in from yesterday. If for some reason you were absent in class and you didn't get that, you need to get that part filled in on your own. And then we'll talk about the multiplying and dividing rules for fractions tomorrow in class. And actually, you could go ahead and fill in the division part because that's what we did on that last slide. Same as for decimals. If you don't have the adding and subtracting filled in yet on your sheet, you need to do that. You need to look them up. You need to, get those from memory. And then we'll talk about multiplying and dividing in class tomorrow. Let's put this into practice. Let's start with a base of negative 1.2 raised to the second power. Remember, with exponents, that does not mean negative 1.2 times 2. It means that I have that base, negative 1.2, multiplied by itself. First of all, it's a negative times a negative, so I know the overall answer is going to be a positive. I'm going to go ahead and write that positive sign so I don't forget. Then I'm going to take 1.2 and I'm going to multiply it times itself. 2 times 2 is 4. 2 times 1 is 2. Placeholder. Add all that up. You get 144. Now, hopefully, you didn't have to do that. What you did in your head is you thought of that as 12 times 12, which is 144. And then you said, I have 2 decimal places, so it's moved over right there to 1.44. Now let's look at practice B. The negative square root of 25 over 81. Think about taking the square root of the top and the square root of the bottom. The square root of 25 is 5. The square root of 81 is 9. This whole thing is negative. So it's negative 5 over 9. And that does make sense. In my head, I think about 5 over 9 times 5 over 9, and I would get 25 over 81. Looking at practice C, 75 divided by negative 0.3. Go ahead and set that up into your division box. The top number goes in the box. 0.3 goes on the outside. Let's deal with the negative. It's a positive divided by a negative, so I know my overall answer is going to be negative. I cannot divide by that decimal. I have to make it a whole number, so I'm going to move my decimal over one place. Go ahead and set that up there. 3 goes into 75 25 times. Oh, that is 75. Whoops. Okay. I do get 0, however, I need to fill in that placeholder. And so it's 250. You likely saw the 25, but what you like to see was the place of the 25. And so it becomes 250. So this is negative 250. And finally, coming over here for negative 5 divided by negative 5 over 3. To divide fractions, I keep it, I change it, I flip it. So let's have negative 5, change it to multiplying, and change the second number to its reciprocal, negative 3 over 5. To multiply a whole number by a fraction, you put that whole number over 1. I can cross simplify. My 5s are both divisible by 5, obviously. They go down to 1, and negative times negative is a positive. What I'm left with is 3 over 1, which is the whole number 3.